This is the Section 3.2 Mathcast. It contains 3 lessons. Probability trees are used as a way to explore situations involving more than 2 categorical variables. Students will encounter a set of particularly challenging probability problems where they will need to use all of the techniques they've learned in the chapter. And students will use their calculators to simulate probability situations they do not have the theoretical models to solve. In Lesson 3.1.4, trees were used as an intuitive place to show conditional probabilities. In Lesson 3.2.1, trees are shown as a way to conceptualize outcomes from more than 2 categorical variables, a limitation of two-way tables. The concept of mutually exclusive events is reviewed from Lessons 1.1.2 and 3.1.1. Students begin by drawing some 3 and 4 variable trees to find specific outcomes. The common situation of at least one is explored, and the complement rule. Then, when challenged with any number of categorical variables, the students see the concept of the tree can be used without drawing the tree. Situations with many consecutive independent outcomes, such as the coin toss, is a preview of the concepts in the binomial distribution, found in Chapter 6. The problems in Lesson 3.2.2 are intended to be challenging. Students have the tools to solve them from other lessons, but will not be able to unravel them by rote. It's okay to tell your students that you expect them to struggle, but be prepared to accept and praise well-documented, messy solutions that show thought. In Lesson 3.2.2, the first 2 problems are a card game version of the classic Monty's Paradox. You might choose to do a class demonstration of the game. The problems in this section are challenging, and you should practice beforehand to increase your comfort level in guiding the students through them. You can find similar problems for extra practice on the problem generator. This section and chapter does not focus on counting principles and assumes that students have some prior experience with combinations and permutations. However, problem 3-54 does include sampling from a deck of cards without replacement. Looking ahead, students will work more with combinations in Chapter 6, along with the binomial distribution. In today's world with so much inexpensive computing power and data available, simulations of probabilistic situations has surpassed theoretical modeling. In Lesson 3.2.3, students will use their calculators to simulate probability situations they don't yet have the theoretical models to solve. Students are not going to be able to come up with every possible way to simulate every possible situation. That's okay. The goal is for them to come up with reasonable ideas on how to simulate these problems. It would be a good idea to practice setting up some simulations on the calculator of your choice to help the lesson run smoothly. Problem 3-66 does preview the law of large numbers, which of course is necessary in understanding sampling distributions later on. Chapter 3 attempts to give students intuitive tools such as two-way tables and tree diagrams to unravel simple probability situations involving categorical variables, and to preview many of the topics required to understand inference with categorical variables found in later chapters.